Let's take a look at question number 36. A wire is wound into 3 square loops and positioned in an external magnetic field as shown. So as you can see here, there are 3 square loops. Now they do seem to be different sizes, but they are the same size. It's just a 3D perspective. And the magnetic field shown below is indicated by dots, which means that the magnetic field lines are coming out of the page or coming towards you. Now, the length of one side of a loop is 15 centimeters for each side of it. And the wire carries an 8 amps current. So we have to, we see that there is a force produced, and the force is 1.5 newtons to the right. So that would be the net force produced to the right. And we have to find out what the value of B is. So we need to find the strength of the magnetic field. So step number 1, we will need to examine the diagram and to determine where what the direction of the current is. So step 1, determine the direction of the current. Now the way we do this is by focusing on the source of energy here. So the long lines will represent the plus side of it, and this is the minus side. And the current will go from plus to minus, so it will be heading in this direction. So we're going to show that on the diagram. Now, in step number 2, we have to determine the forces because that's what we're working with. We're working with forces. We're given a net force. So this net force will help us determine the value of the strength of the magnetic field. Now, to determine the to determine the forces, we're going to use a right hand rule. So you're going to hold your hand coming out of the page and toward you, and try to twist your hand and in such a way that your thumb, so remember the 4 fingers will be pointing at you or coming out of the page, and the thumb has to follow the current. Now the direction of the force, magnetic force, will be the force that is coming out of your palm. Okay, so try to do this for each side of the wire because as you can see, the direction of the current on each side of the wire is different. So here is to the left, here is up, here is to the right, and this is down. So when I hold my hand towards me with 4 fingers aiming at me, and I twist my hand, still the 4 fingers towards me. I twist my hand so that I can follow the direction of the current. I see that the palm here is going to be facing this way, which means that this was going to be the up force. Now keep twisting your hand as you follow the current, so same position, your 4 fingers coming out of the page, and just let the thumb follow the current, and you'll see that this time here for this side the palm is going to face this way, so this would be the magnetic force for this side of the wire. In the same way, you'll find that the magnetic force on this side of the wire will be going down and the magnetic force will be going this way. So what we're going to do is try to write them all, draw all the forces in here. Now, very important to focus on is that the net force is 1.5 newtons to the right. Now, as you can see here, we have many forces participating, magnetic forces participating in this diagram. So we have magnetic force up and down. Now, since the wire is not moving up or down, it means that these 2 magnetic forces are in equilibrium. So they must have same magnitude and opposite in direction, which is obvious. Now, since the force is to the left, and since the net force is 1.5 Newton to the right, it means that the left and the right forces, so they're not in equilibrium, and it seems that since it is moving to the right, the magnetic force to the right must be greater than magnetic force to the left. This is very important to analyze before we start calculating the magnetic field, because we have to use a force to find the magnetic field, right? And we need to figure out what force we use and why do we use the one we do and the way we do. So we're going to write down all the explanations that we were talking about right now. So since the given force is directed to the right, it means that number one, the force to the right is greater than the force to the left, and that makes the net effect to the right. And number two, it means that there is no up or down motion, meaning that the force up plus the force down is going to be equal to zero, which makes the force up equal to opposite of the force down. So these two are in equilibrium. Now we have to think, we have the force, it is equal to 1.5 newtons to the right, and we need to know what the magnetic field is. Now, for this, we're going to use the formula. So for this, we're going to use only on the net force that is, or on the force that is producing the net effect, which means the force to the right. And the formula that we use is ILB sine theta. Now, here is another thing we need to focus on. First of all, we are going to isolate for B, and that is common routine. That would be F over IL sine theta. Now, when you substitute, it is very important that we use only the net force to the right. And the current is going to be 8 because the current is the same throughout the wire. And the length of the wire here is 15 centimeters or 0.15 meters. But remember that because we have 3 wires in this direction, so all 3 of them are contributing to this net force, which means that the total length that we consider here is the length of this wire times 3. So we're going to multiply by 3, 0.15, because there are 3 loops. And then you multiply by the sine of 90. Now, why sine of 90? Remember that angle theta is the angle made between magnetic field and the wire. And you see that the wire is, laying flat on the table and magnetic field is coming out of the table, so the angle between them is 90 degrees. And from here on, it's very easy and very simple. You simply put the numbers in the calculator. Is 0.417 Tesla, and if you round it to 2 decimal places, is 0.42. So and this is it. So, and we know that the direction of the magnetic field is actually coming towards us, so out of the page. So if you want to emphasize that, because it is actually given. All right, so I hope you found the instructions useful and this made sense. Thank you for learning with me. Bye for now.